Now let us try to understand how to find out the resultant of non-concurrent force system. A bar ABCDE is subjected to the forces as shown in the figure, and we have to find out the magnitude and direction as well as the point of application of the resultant. Now this point of application part is very important. So as shown in the figure, the distance between A and B is 2 meter, between B and C it is 2.5 meter, between C and D it is 3 meter, and between D and E it is 1 meter. At point B, 30 Newton force is acting, making an angle of 90 degree with AB. Horizontal force of 50 Newton is acting at point C. Vertical force of 20 Newton is acting at point D. And the force of 10 Newton is acting along this particular bar. Now, as we can see over here in this particular right angle triangle, this total length AC is 4.5 meter, and the angle that is made with the horizontal by this particular bar is 30 degree. So this length will be 4.5 cos 30. Similarly, the length from A to D is 7.5 meter. So this is 2 meter, 2 plus 2.5 plus 3. So that is 7.5 meter. And again, the angle made by this particular bar with the horizontal is 30 degree. So this horizontal component is 7.5 cos 30. Similarly, we can calculate the vertical components also. So this is angle 30, opposite component is the sine component. So this is 4.5 sine 30. Similarly, this will be 7.5 sine 30 because angle is same, that is 30 degree. Now, this particular 10 Newton force is making an angle of 30 degree with the horizontal. So it will have two components. One is cos component, that is 10 cos 30, and another one is sine component, that is 10 sine 30, and point of application is E. Now, as this is 30 degree and this is 90 degree, this angle will be 60 degree. So we can say that this 30 Newton force is making an angle of 60 degree. So again, it will also have two components. In horizontal direction, it is 30 cos 60, and in vertical direction, it is 30 sine 60. Now let us find out the summation of forces in x direction by assuming the convention that forces towards right, they are considered as positive, whereas forces towards left, they are considered as negative. So these are the conventions that we have followed. So as we can see over here, this 10 cos 30, it is acting in the positive x direction. So that is positive, which we have written over here. This 50 Newton is acting in the negative x direction. So it is minus 50. Whereas this 30 cos 60, it is along positive x direction. So that is positive 30 cos 60. And therefore, we will get summation of Fx is equal to minus 26.34 Newton. Similarly, we can find out what is the summation of forces in y direction by using the convention that is upward forces, they are considered as positive, whereas downward forces, they are considered as negative. So summation of Fy will be equal to, we can start with this first force, that is 10 sine 30, it is acting in the downward direction, so it is negative. Then this 20 Newton force, correct, it is acting in the upward direction at point T, so it is positive. Whereas this 30 sine 60 is also acting in the upward direction, so that is also positive. And therefore, summation of Fy, when we make the calculation, we will get the answer as 40.98. Now the resultant of this particular force system is square root of summation of Fx square plus summation of Fy square. Substitute the values and we'll get the value of R as 48.715 Newton. Similarly, we can find out what is the angle that is made by this resultant. So theta is given by tan inverse of summation of Fy divided by summation of Fx, and we have to take the mod values of this, and therefore we have not considered the negative sign over here, and the angle that is made by the resultant is 57.27 degrees. Now, as summation of Fx is negative that we have already obtained and summation of Fy is positive, we can say that this resultant R will lie in the second quadrant. So we have calculated in this particular case the resultant in magnitude as well as in direction, but the point of application also we have to find out. Now we'll take the moment about point A by assuming the convention that clockwise moments are considered as positive, whereas anti-clockwise moments they are considered as negative. So R into X, where X is the distance or point of application of the resultant, will be equal to. Now this is important part. So this, as we are taking moment about point A, this 30 which is acting in the perpendicular direction will produce the clockwise moment about A, and hence it is positive. So 30 multiplied by perpendicular distance from this point to this point, that is from B to A, is 2 meter. So 30 into 2, that is positive clockwise moment, and hence it is positive. Whereas this 50 will produce anti-clockwise moment about A, and 50 force is horizontal, the distance, vertical distance we have to consider perpendicular, so that is 4.5 sine 30. Then this 20 Newton force will produce the clockwise moment about A, and hence it is positive, and this 20 Newton force is acting in the vertical direction, so we have to consider this horizontal distance of perpendicular distance of 7.5 cos 30, and therefore it is 20 into 7.5 cos 30. So substitute the value of R, that is 48.7.5, and we'll get the value of X as 1.59 meter. So we can say that the resultant is acting in the second quadrant, and it is acting at a distance of 1.59 meter from point A. So from A, draw a circle of 1.59 meter as shown over here, and from point M, draw a tangent, which is nothing but our resultant. The resultant is making an angle of 57.27 degree, as we have already calculated, and we can say that this is, as we have already seen, that the resultant is in second quadrant. So this is the first quadrant, and this is the second quadrant. So we have considered this as y-axis and this as x-axis. So this is first quadrant and this is the second quadrant. So R is acting at an angle of 57.27 degree in the second quadrant, and the perpendicular distance between these two, that is R and A, is 1.59 meter. So in this way we can find out the point of application of the resultant.